I wish I could pretend I didn't need you. 5.2, factors. All right, so we've done factoring before, but now we're going to do it with bigger polynomials. Let's see what I mean. Like this one, we used to just do factoring x squares, doing two parentheses. We had a whole bunch of different methods to do it, but now we're going to raise the degree of the polynomial. Let's go ahead and try to factor x to the third power minus 2x squared minus 15x. Well, the one thing you can pull out is you can pull out an x out of all of that. And then now we just have a quadratic on the inside that you can factor traditionally using your two parentheses. And there it is. X times the quantity of x minus 5 times the quantity of x plus 3. All right, so not too difficult. Let's try another one. How about 10x squared plus 2x to the third plus 12x? The first thing you want to do is put it in standard form. List it from least to greatest with the degrees. Now let's see what we can pull out to the front. It looks like I can pull out a 2 and an x. So let's go ahead and pull out the 2 and the x. And now you can just factor the inside because it's just a regular quadratic. And there we have it. 2x times the quantity of x plus 2 times the quantity of x plus 3. Not too bad. Let's move on. Let's go ahead and solve some of these using the zero product property. Remember, that's when you take each set of parentheses and set it equal to 0. All right, so find the zeros of the functions and find each of its multiplicity, then graph. Ooh. All right, so if you set this equation equal to 0, make this f of x equal to 0, and then you set each parentheses equal to 0, you have x equals 0, you have x equals negative 2, you have x equals 1, but notice there's a squared in there. So actually x equals 1 happens twice. We say that 1 has a multiplicity of 2. So basically the answer 1 happens twice, and it's kind of important. And then the last answer, x equals negative 3 over 2. All right, so those are our answers just for that equation. Now they ask you to graph it. I'm going to try to draw this out. On the homework, it's just an estimate graph, but you do need these key points. We know one of the answers is x equals 0, so there's one. X equals negative 2, here's another one. X equals 1, that happens twice, and we'll see what that looks like in a second. And then x equals negative 1.5, and that's right around here. All right, so we know our graph is a positive graph because the very front, or if you FOIL everything out, you'll have a positive coefficient. So it should look like a positive. The degree is x to the first, x second, third, fourth, fifth. It's going to look like a graph that is x to the fifth power. And so let's see what that looks like. We're going to start off, and then it's positive, so it's going to look like this. The end behavior, the left side's going to be down, the right side's going to be up. So here's what my guess is the graph is going to look like. It's going to start down here. It's going to go up, and then I don't know how far up, but it does cross that negative 2, and then it goes back down again, and then it goes up again. And then remember, at 1, it actually hits the point twice. So here's what that looks like when it hits the point twice. 1, 2. All right, so that's important. At 1, it actually hits the point twice, and you don't really see it because it doesn't go through. It just hits it and then it bounces up right away. And so that's what our graph looks like. It's a very ugly estimate, but that's how it looks. Let's try another one. Here it is. I'll erase this one over here. All right, so let's go ahead and solve. Set the g of x equal to 0. That means you can set all the parentheses equal to 0. So that means our first x is 2. And then our second answer is -1, but that happens 3 times. All right, so let's see what that looks like in a graph. There's my x and my y. We know one of the answers is at 2. There it is. And then -1. That happens 3 times. And I'll show you what that looks like in a second. All right, if you were to FOIL all of this out, you would have a graph that is, in general, x to the 4th power, just because we have x to the 3rd here, and then another x, which is going to give us x to the 4th. And graphs with x to the 4ths look like this. They're positive. There's going to be inflections in here. I didn't draw the inflections, but it should be like wiggly in here, kind of like a W. All right, so here's how that's going to look on our graph. The left side is going to go up. And then remember, at -1, we have to hit it 3 times. So I hit it once, and then I'm going to go up twice, and then 3 times. So I know you can't see it very well, but a lot of action was happening at -1. It was down 1, 2, 3, and then at some point it's got to hit there. So there it is. Now there's no real inflection in here. I just kind of mimicked it just so that you can see what's happening when there's a multiplicity that's more than 1. It kind of just hits in that spot. But hopefully you can see what I'm trying to show you with the inflections. All right, let's move on. This one says tricky. All right, and it's not too bad. You just have to now factor this yourself. So let's go ahead and set it equal to 0. And then I can pull out an x squared, which is what I did. And then you can factor the quadratic on the inside. And there it is. And now we can solve for each x. There it is. X equals 0 happens twice because of this part. X squared. So x equals 0 has a multiplicity of 2. And then x equals 4 and x equals -2. All right, if we were to graph this, let's go ahead. They're not very pretty, but that's what we got. X equals 0, this happens twice, remember, so when it happens twice, there's going to be a little bit of action right there. 1, 2, 3, 4, it'll cross here, and then -2, it'll cross here. All right, we have a graph that's x to the 4th power, so again, it should look something like a W. Let's see. Here it is. It goes through this. And then remember, there's action happening at 0 because it's multiplicity of 2, so it's 1, 2. And then, of course, up again. So there's our very rough estimate of our graph. And I don't know how deep these loops go. We're going to analyze that later on in this chapter, but for now we're focused on the zeros. Okay? Going backwards, All right, what if they give you the answers? What if they tell you the answer is -2, 2, and 3? You have to come up with a function that got those 3 answers. How do we do that? We just work our steps backwards. So there are the 3 answers. Let's throw them in parentheses. When you throw them in parentheses, remember you're using the opposite sign. So x plus 2 times the quantity of x minus 2 times the quantity of x minus 3. And then all you got to do is superfoil. All right, I decided to go ahead, and it doesn't matter the order you foil it in, but I decided to do these 2 first. So I foiled them together, combine like terms, and now I'm going to distribute the x into all 3 of these, and the 2 into all 3 of these. Okay, when I do that, this is what I get. Combine some like terms, and there it is. There's the function. If you were to solve that, would give you those 3 answers. All right, let's do another one of those. X equals 4, -1, and 1/2. Let's throw those in parentheses. F of x is equal to x minus 4 times the quantity of x plus 1 times the quantity of, here's the tricky part, how do we get this answer? From here. Okay, remember if you were to solve it, you would get 1/2. So try to use your brains to do that one, and then foil. Again, I usually like to foil the last 2 first, and I don't know why, you don't have to. And then go ahead and distribute that in. And combine like terms. And there we have our cubic. Okay? Last slide of the day. All right, graphing. We're gonna use our calculator to graph this cubic equation. Normally I would tell you to use your graphing calculator, which you still can, definitely, but go ahead and also learn how to use Desmos, the online tool that I showed you already. Right? When you throw it in Desmos, that's what it looks like. They want you to find the relative max and the relative min. This is the relative max. It's called relative because it's not the very maximum point, but it is a vertex that is at the top. So that is called a relative max, and then this down here is called a relative min. And on Desmos, you can go ahead and find those relatively easily, Those are the points. On your graphing calculator, you would have to find the max and the min by trapping these two, left bound, right bound. This one, left bound, right bound. And then you would trap it, and then your calculator will tell you the same answer. All right, and then you also have to do the max and the min, the increasing part and the decreasing part. So clearly from here to here is increasing, and from here to here is also increasing. So the way we write that is from -infinity, this is -infinity, all the way to this point, which is -4. That's increasing, and then this point at 2 all the way to +infinity. That's increasing. And the only part that's decreasing is right here from -4 to 2. And so that's how you write it, decreasing from -4 to 2. All right, go ahead and try your homework. Have fun with it.